हम लोग को स्क्रीन दिखाई दे रहा है?
यस सर।
स्क्रीन दिख रहा है तुम्हें?
यस सर।
हाँ सर।
नहीं सर, नहीं दिख रहा।
दिख रहा है सर।
ठीक है, तो हम लोग आगे चलते हैं कैरेथियोडोरिस थ्योरम पर। देखो, let A belongs to I which is subset of R, and let F be a function defined on I. Then F is differentiable at A if and only if there exists a continuous function psi x on I such that fx minus fa is equal to psi x into x minus a for all x in I. That is, we have psi a is equal to f dash a. See its proof. Let f is differentiable at x is equal to a. It means f dash a exists karega. Now we can define psi by psi x is equal to fx minus fa over x minus a for x not equal to a and x in I, and f dash a for x equal to a. तो ये psi x का डेफिनेशन दिया हुआ है यहाँ पर, तो उसी को हम लोग डिफाइन कर रहे हैं और हमें ये चीज प्रूव करना है। Since psi is continuous, so limit psi x tending to a will be f dash a. Continuity का डेफिनेशन यही कहता है, लिमिट ऑफ द फंक्शन इक्वल टू वैल्यू ऑफ द फंक्शन. If x is equal to a, then both sides of fx minus fa equal to psi x into x minus a is 0. ठीक, x equal to a रखेंगे तो 0 दे देगा. So let x be not equal to a. Then psi x is equal to fx minus fa over x minus a for x not equal to a. By multiplying both sides by x minus a, we get fx minus fa is equal to x minus a into psi x for all x in I and x not equal to a. तो ये फर्स्ट पार्ट हमारा प्रूव हो गया. इफ एंड ओनली इफ का एक पार्ट हमारा प्रूव हो गया. नेक्स्ट कन्वर्स. Let psi x is continuous at a and satisfying fx minus fa is equal to x minus a into psi x for all x in I and x not equal to a. Now dividing both sides by x minus a not equal to 0, then the continuity of psi implies that psi is equal to limit psi x tending to a. This is equal to limit fx minus fa or x minus a tending to a exists. Therefore, this f is differentiable at a and f dash a is equal to psi a. This is your f dash a and this is equal to psi a. तो ये इसका जो कन्वर्स है वो पार्ट भी प्रूफ हो गया, ये भी ठीक है. इसके बाद एक और थ्योरम है, थ्योरम 3.5.2. तो अभी पिछले वाले में कोई क्वेश्चन तुम लोग को अगर पूछना है तो जल्दी से पूछ लो, मैंने नोट करना है तो जल्दी से इसको नोट कर लो ताकि हम लोग फिर आगे चलें. Now this is your next theorem. Theorem देखो, let I1 I2 be intervals in R. Let F1 be a mapping from I1 to R and F2 be from I2 to R. Be functions such that F2 I2 is contained in I1. And let A belongs to I2 if F2 is differentiable at A and if f1 is differentiable at f2a, then the composite function f1 over f2 means is differentiable at a, and f1 composition f2 dash a is equal to f1 dash f2a into f2 dash a. इसका प्रूफ देखो, since f2 dash exists, ये लिख रहा है f2 is differentiable at a, so f2 dash exists. By Caratheodory's theorem, there exists a function psi on I2 such that psi is continuous at a, and f2x minus f2a is equal to psi x into x minus a for x in I. And psi a is equal to f2 dash a. Also, it is given that f1 is differentiable at f2a. ये दिया हुआ है f1 is differentiable at f2a. So f1 dash f2a exists. अब f2a एक एलिमेंट हो गया और f1 differentiable है, so f1 dash f2a exist करेगा. So by Caratheodory's theorem, there exists a continuous function phi defined on I1 such that phi is continuous at b is equal to f2a, and f1y minus f1b is equal to phi y into y minus b, and phi b is your f1 dash b for y in I. Now put y is equal to f2x and b is equal to f2a in 3. इस इक्वेशन में y is equal to f2x रखिए, तो हो जाएगा f1 f2x minus f1 और b की जगह f2a रख लीजिए minus f1 f2a. This is equal to phi f2x and within bracket f2x minus f2a. So this is equal to phi f2x into f2x minus f2a is this one, psi x into x minus phi 1. Now phi is continuous at f2a and psi is continuous at a. There, since phi composition f2 is continuous at a, since f2 is differentiable at a, it is given. Phi o f2 psi is continuous at a, or phi f2x psi x is continuous at a, or equation 5, this can be rewritten as f1 composition f2x minus f1 composition f2a is equal to phi composition f2 psi into psi x into x minus a, and phi composition f2 psi is continuous at a. So by Caratheodory's theorem, f1 composition f2 dash a exists, and phi composition f2 into psi a is equal to phi f1 composition f2 dash a. Caratheodory's theorem यहाँ पर लगाएंगे. Since psi a is f2 dash a and phi b is f1 dash b, or phi f2a is f1 dash f2a. Now substitute this in 6, then you get f1 dash f2a into f2 dash a is equal to f1 composition f2 dash into a. So this proves the theorem. तो इसको भी आप लोग नोट कर लीजिए. अगर कोई डिफिकल्टी है तो मुझे पूछिए. अब एक एग्जांपल देख लो. Prove that the function fx is equal to mod x is continuous at x equal to 0, but not differentiable at x is equal to 0, where this mod x is the absolute value of x. See, continuity at x equal to 0. f0 plus 0 means right hand limit is limit s tends to 0, f0 plus s is equal to limit s tends to 0 fh. So this is limit s tends to 0 mod h. It means mod h is your h, so it is limit s tends to 0 h, and it is your 0. Similarly, left hand limit f0 minus 0 is equal to limit f0 minus h, limit f minus h, limit modulus minus h, limit h, it is equal to 0 when s tends to 0. So f of 0 is equal to modulus 0, it is your 0. So left hand limit is equal to right hand limit, it is equal to f0 is equal to 0. So limit of the function is equal to value of the function. Therefore, the function f is continuous at x equal to a. Now we need to check the differentiability at x equal इक्वल टू 0। और कुछ नेटवर्क का प्रॉब्लम होगा, इधर से तो ठीक है, इधर से तो एकदम ठीक है, नेटवर्क का इशू होगा, आवाज जो धीमे जा रही है। नाउ डिफरेंशिएबिलिटी एट x इक्वल टू 0। देखो पहले लेफ्ट हैंड डिफरेंशिएबिलिटी LF डैश 0 is equal to limit f0 minus h minus f0 over 0 minus h minus 0 h tending to 0. So limit h tending to 0 f minus h minus f0 over minus h. It means limit h tending to 0 mod minus h minus 0 by minus h. Mod minus h is your h. So it is limit h tends to 0 h by minus h means minus 1. So left hand derivative is minus 1. Now right hand derivative rf dash 0 is limit 0 plus h minus f0 plus h minus f0 by 0 plus h minus 0. So f0 plus is fh minus f0 by h. Fh is your mod h minus 0 by h. So it is limit h tending to 0 h by h. Means its value is 1. See, left hand derivative is minus 1 and right hand derivative is plus 1. So the function f is not differentiable at x equal to 0. तो इस तरह से आपका ये प्रॉब्लम सॉल्व हो गया. Means this function is not differentiable at x equal to 0. इसी तरह से एक और एग्जांपल है, इसको भी हम लोग देख लें जल्दी से. Discuss the derivability of the function fx equal to x for x less than 1, 2 minus x for 1 less than or equal to 2, minus 2 plus 3x minus x square for x greater than 2 at x equal to 1 and x equal to 2. यानी x equal to 1 पर डेरिवेबिलिटी और x equal to 2 पर इसकी डेरिवेबिलिटी हमें चेक करनी होगी. तो जैसे हम लोग पहले किए उसी तरह से यहाँ पे अगेन करेंगे प्रॉब्लम सॉल्व को. तो लेफ्ट डेरिवेटिव differentiability at x equal to 1, LSD is your limit fx minus f1 or x minus 1 x tending to 1 minus 1. So it is limit x minus 1 by x minus 1. क्योंकि fx is your x and this is your 1. And right hand derivative is limit fx minus fx1 over x minus 1 x tending to 1 plus. So it is when x is tending to 1 more than 1, then fx is 2 minus x minus 1 by x minus 1. So it is your limit 1 minus x by x minus 1 and its value is minus 1. तो यहाँ पर क्या हो गया, लेफ्ट हैंड डेरिवेटिव इज नॉट इक्वल टू राइट हैंड डेरिवेटिव. तो यानी कि ये हमारा f is not derivable at x equal to 1. Similarly, you can show that left hand derivative at x equal to 2 is minus 1 and right hand derivative at x equal to 2 is minus 1. So both of them are equal and f is differentiable at x equal to 2. तो इस तरह से आपका ये वाला एग्जांपल भी हो गया. जल्दी से इसको आप नोट करिए, कोई प्रॉब्लम है तो मुझे पूछिए.